I'm curious. I am curious. Curious.
By nature.
Welcome to Curious by Nature. I'm Jessica Johnson with Newswise. When studying wildlife in remote parts of the world, getting there to do the work is an enormous challenge. Traveling to Antarctica to study emperor penguins, for example, is very expensive and time-consuming, and you can only go at certain times of year. Imagine if wildlife biologists could do their job remotely. Our guest this time takes remote work to an entirely new level, using satellite imagery to study animals from space. It's giving unprecedented access to these hard-to-reach places, along with crucial insights into the effects of climate change on the sensitive Antarctic ecosystem. Dr. LaRue, welcome. Please introduce yourself.
My name is Michelle LaRue, and I'm an associate professor in the School of Earth and Environment at the University of Canterbury in Christchurch, New Zealand.
Can you tell me about your work and more of what you do?
So kind of my one-liner of what I do is that I study animals from space. And what that means is I use Google Earth type imagery, so this real high resolution imagery that you can see on like Google Earth, and we can actually see animals using that imagery, which means that we can visually look at some really remote places on Earth, including Antarctica. And so for the past 10 or 15 years, I've been using that as a tool to learn about emperor penguins, Adelie penguins, weddell seals, and crab-eater seals in the Southern Ocean. When we're looking at these animals from space, what's really funny is that you kind of have to think about what the animal is doing at the time that you're looking at the imagery, because they do different things at different times of year. So for example, one of the species that I study are emperor penguins, which I often introduce as kind of like really needing no introduction, but for just to clarify like how we're looking at them from space, what we're looking for is this big brown smudge on the fast ice. So the fast ice is this frozen seawater. It's sea ice that's fastened to either the Antarctic continent or to a glacier or like an ice shelf. And so that's where they tend to live. They live right next to the continent, but they don't tend to come on land. They're just on the ice. And so that's really convenient because when we're looking at them from space, we can see immediately whether or not they're there because they leave this brown smudge, and that brown smudge is their guano. Another way of saying poo or scat. And so we can hone in and say, okay, we know that they're there. But then when we get high resolution images back, and it's even higher resolution, and when I say high resolution, we're talking anywhere from about 30 centimeters to 50 centimeter resolution. So it's kind of like, about a foot, a little less than a foot roughly. And what that means is each side of a pixel is about that big. So basically, like I said earlier, it's like the Google Earth type imagery. You can see, people's cars and trees and things like that. It's just like that. So it's really fine resolution, and we can actually see individual emperor penguins. And so when you zoom in even farther, not only can we tell that they're there, but we can actually count them and figure out how many there are at every colony around Antarctica over, basically in perpetuity. And that's a really powerful tool because we've never been able to do that prior to about 2009 or 2010. So now we have this capacity to actually figure out how the population was doing back then, and be able to monitor them into the future.
How do you know that they're emperor penguins?
That is a fantastic question. The reason we know they're emperor penguins is because at that time of year we're looking, which is in the springtime, that's the only bird that would inhabit the sea ice the way emperor penguins do. So the only other penguin that is extant around the entire continent is the Adelie penguin, and they nest on land. So there's this really nice kind of habitat segregation between the two birds. And then furthermore, the Adelie penguins don't come back to Antarctica until probably October. Roughly October is when they come back, and the emperor penguins famously come back in April.
So what is happening with emperor penguins since 2009?
As we're looking at them from space, we're learning about all kinds of other things that they do that we didn't know they did. So for example, we've made some observations that sometimes the colonies are present in a particular year at a particular spot, and then the next year they might not be there. And that completely, for me, again, as a wildlife ecologist, is like, okay, well, what are they doing? Like, where are they going? What are they doing? What does that tell us about how we should be interpreting their population changes? So that's a real important piece of information that we are still kind of trying to figure out. The other thing that we know that they do is they're not always on sea ice, like I suggested. Sometimes they will go on land. Sometimes they will hop up on a nearby ice shelf or glacier. And those are also things that we realize they do only by looking at them from space. So it actually, even though we're getting like a really great idea and good spatial coverage of what the populations are doing, they're also doing things that we didn't really expect. And so we kind of have to like throw that into the mix and like work that into our interpretation. So with all of that said, what we have found over the past 10 years, from 2009 through 2018, the emperor penguin population that we're seeing from space, so that's animals that we're looking at in the springtime, has probably decreased by about 10%.
Who are the predators of the emperor penguins?
Leopard seals will very famously hang around some of these larger colonies, and they'll kind of like cruise by underneath the fast ice, which is interesting. And I think there has been an observation or two of orca taking emperor penguins, but I'm not super sure that's really common. So it's primarily leopard seals.
What else have you seen from your research of emperor penguins?
For me, I think the blinking is the thing that's really interesting to me. Like that's what we call sometimes when the colony's there, sometimes when it's not. And to me, that's one of those like, why are they doing that? Is this a bad place to be? Do they somehow know it's going to be a bad place before they arrive in the wintertime? Like, do they arrive and go, this ice is terrible, we're gonna head out, we're not gonna try to breed this year, we're gonna go somewhere else? Or, do they join another colony? So that's for me one of the things that I think is really interesting.
Why should other people who aren't studying emperor penguins care about emperor penguins other than that they're cute and cool animals? Or reasons why more people should care about them?
They're here and they're super cool for all kinds of reasons, but like they're around and they've been around for millions of years. And so I think from the perspective of trying to understand them and conserve them and make sure that we are not altering their populations in a negative way as best we can. To me, the reason they're really important to study is because they have been around for millions of years. They're technically dinosaurs that, are still here. And I think there's a lot to learn from them about, if we want to anthropomorphize just a little bit for a second, like to think about their resilience. Like these are animals that have been around for millions of years that have for some reason focused on nesting on sea ice, which is a terrible place to nest. Why would you do that? It's a place that literally disappears every single year. Like that's not a great place. Why did they decide to do that? They've been doing this for millions of years. Why? How are they doing this? Clearly they have a sense of resilience to be able to deal with all of these different interglacial periods and things like that. Not only scientifically, but also kind of just thinking about, well, how would these animals deal with these extreme conditions? And is there something that we as humans can learn from them about that? But then beyond that, there's just cool. And I think there's nothing wrong with wanting to study and understand animals that are really neat and beautiful. And let's be honest, like the chicks are probably the cutest things on earth.
Yes. What are things that I guess you have learned and applied to your life from studying emperor penguins?
When you're sitting with them long enough and when you're watching them long enough, you observe certain behaviors and stuff, and you observe this, like I observe in myself, like this very sense of calm when I am anywhere near them because they're very chill for the most part. Not to say that they can't flip out, they can. And I've seen that too, but they do just have this, like they kind of just sit there, like, especially when you're around the chicks, like what they're doing at the time of year that I have seen them is they're trying really hard to maintain their body mass. They're trying not to move a whole lot. They're waiting for their food, etc. And they're also waiting to fledge those downy feathers. So they're not really doing a whole lot, which to me, I think is kind of an important reminder to like be present and mindful. And it's okay to just like sit and observe your surroundings. And when you're surrounded by, thousands of emperor penguin chicks, it's not really a hard thing to do. No. So yeah, I think the reminder to kind of just like relax and be aware of your surroundings is something that I've learned from emperor penguins.
And tell me how they flip out.
In my experience, they don't do it all that often. But what they do is when they get to the edge of, like, this is the adults now that I've seen, when they get to the edge of the ice, they'll all kind of like get to the edge and nobody jumps in first. Like everybody kind of just like waits for an indeterminate amount of time. And then at some point, they either get pushed or shoved, or somebody at the back makes a mistake, and they kind of like all have to just go in. And it's not just one, they all go in together. And so there's this kind of like, you can kind of see this like, okay, here we go. I guess we're all going in now. And they kind of don't have a choice, and they have to like, I think there's this like very teeny tiny little moment of like, and they're freaking out a little bit, but then they realize like, okay, once we hit the water, we've got to go, because there could be a leopard seal here, and we've got to get out of here as quickly as possible. So I think there's that like anticipation, and then this like, okay, well, here we go. We're all going in this together, and off we go to go forage.
Did you start research in emperor penguins when you were at the University of Minnesota?
I did, yeah. So I started my research there, and I remember, I can't remember if I saw emperor penguins on satellite imagery first or Weddell seals. I'm gonna have to like go back in my emails and figure this out, because I actually don't know which one I saw first. But I do remember my boss at the time coming to me and saying, "Michelle, I think we can see Weddell or emperor penguins from space," and I did not believe him. And then he showed me the image, and I was like, "Oh wow, I am way off. That is really really cool." And so yeah, that really opened up this whole new avenue of doing wildlife ecology.
And so then when you first saw them, were they small dots? And now what are they like?
Yeah, so when we first saw them, I remember looking at the ice and seeing the guano stain, that like really dark brown guano stain. And my first instinct was that it wasn't guano at all, but that it was kind of dirty sea ice. And that can happen pretty easily as well. It can be difficult at times to tell the difference between kind of ice that's where the algae has kind of come through and gotten to the surface, or if it's actually guano. So that was my first instinct, is that it wasn't guano at all. But as you looked a little bit more closely, you could definitely see little black dots kind of all over the place. And it was very obvious that we can see the birds. As far as the way they look now with higher resolution imagery, it's pretty much the same. It's just, you can probably kind of see more of them, and you can see more individuals. Whereas I think maybe 10 or 15 years ago, we could see groups of them a little bit easier, and now we can see individuals easier.
Very exciting. And it will improve, like you said, with the satellite imagery becoming more stronger and get better. So what do you think you'll be able to do in the future?
So I think that's also an important thing to remember, that when we're looking at the imagery, like the Google Earth type imagery that we've been talking about, that's what's called optical imagery, which means that the sun has to be up in order for you to capture an image. So like if you've ever taken a picture in the dark and you didn't have a flash on, you can't see anything, right? It's the same thing with these satellite images. The sun needs to be up. But there are ways of detecting and sensing the Earth without the sun being up. You can do it in the dark. And that's called synthetic aperture radar. And those images tend to be really coarse resolution, where it hasn't been possible to do this in the past, as in like, tens of meters of resolution, where you're not going to be able to see individuals or probably even groups of penguins. But now the technology has gotten so good that it is matching that optical resolution imagery. So it's anywhere like 30 to 40 centimeter resolution, which suggests that we may be able to see these animals in the dark in the wintertime when they are huddling. And we would, for the first time, have an indication of what the breeding population is doing. And so to me, that's the next transformation, is because over the past, ever since we've been able to see them from space, we are only seeing them in the springtime. So we're not getting a good idea of the breeding population. But with this SAR imagery, looking for them in June or July, when all the males are huddled together, we could for the first time have an understanding of what the breeding population is doing. And that would be a huge, huge win for us.
And what are their patterns of movement? You said all the males are huddled together.
So emperor penguins have, so oftentimes when we talk about them, we talk about this like very rigid pattern that all of these penguins and all of these colonies do the same thing over time. And I do not think that that's the case. I think that they do the same types of things, but the timing of year and when they do it and how long it takes, I think is pretty variable. So in general, what happens is maybe in like late March, beginning of April, everybody comes back to the colony. Everybody who wants to try to breed and have a chick this year will come back to the colony, and that's where they do their mate selection, and they'll pair up. And then they'll mate over the course of, a couple of weeks. An egg will be laid, and then as soon as that egg is laid, the female passes it off to the male, and then she leaves for several months. And so it's that timing of all of the females like lay their eggs, and they all head for the ocean literally, and then the males have to starve themselves and incubate this egg for a couple of months while the females are out. And so they huddle together to stay warm in the very, very cold Antarctic winters. And then as soon as the chicks hatch, which is, a couple months later, the hope is that the females will come back right at that time. Like they'll time somehow. Because they're going to be nice and full and full of food, and we'll be able to relieve the male and start feeding the chick. And then that transition happens where the females will then take the chick, and then the males go out and eat as much as they can. And they'll go back and forth like that for essentially the rest of the season. But it's that middle time of year when it's only the males. We know the males are the ones doing the incubating. If we can count how many there are, we can just literally multiply it by 2, and then we get the breeding population. And that's never been done before.
Is there any question that I didn't ask you that you would like to answer?
I think the only other thing that I'll just mention is that the other thing we need to keep in mind as humans and also as scientists and ecologists is that these animals are not operating in a vacuum. So we often in contemporary science, we often will say that we're going to isolate emperor penguins and study just them. But that is a completely unrealistic view of the world, because they don't have the open ocean to themselves, right? They're going after prey, obviously. That prey is being influenced by the phytoplankton, which is being influenced by the sea ice. They're being influenced by other predators that are around, their competitors potentially. And so the more information that we gather, hopefully from space, and this is where another place where I hope to help provide context, I guess, about what's going on in the ecosystem, is to start putting the pieces of the puzzle together about animals that are kind of in that same realm as emperor penguins, as in as many animals that are going after a silverfish and krill. Can we study them together and get a better idea of how the ecosystem is functioning? Can we get a better idea of whether or not those populations are influencing each other? Maybe they're not. Maybe they're coexisting completely fine, but we don't know the answer to that question yet. And so that's one thing that I think we also need to keep in mind, is if we can have a more holistic view of what's going on in the ocean, I think the better off we will be.
If you could complete this sentence, I'm curious about.
I am curious about why animals do the things they do. Now, that sounds very broad, but is kind of intended to be that way, because what I think happens in Antarctica is I think that there is not really a one-size-fits-all explanation or reason that animals do things that they do. So, for example, I think that for emperor penguins, in some places, the populations may be driven by prey availability. And I think in completely different locations, they're driven by, sea ice availability. So they're going to make decisions about when they come back to their colony, if they come back to the colony, how often they try to breed or mate. Those are going to be completely different reasons for making those decisions. And then that feeds up and kind of trickles up into how we look at them from space. And so what I'm trying to do and what I'm curious about is how we can get as fine a detail about what they're doing and why, to better understand how they relate to their system, to the ecosystem. And then furthermore, when questions come up about conservation and what can we do to help them, I think a finer, detailed approach is more appropriate. And if we can provide that information to allow for that finer, detailed approach, that would be my goal as a scientist.
Thank you so much.
Curious by Nature is a production of Newswise. More than 7,000 journalists get the Newswise wires. Visit newswise.com and find out how to spread your news today.